Good evening, everyone. Before we start today's session, please feel free to do event check-in. This will give you access to additional resources and information about events that we are running on Reactor, which are around similar topics to today's session. I will share the QR code in the Q&A section shortly. Also, we have launched our Reactor group on LinkedIn. Please feel free to join the group to get the latest update on session happening on Reactor. I will share the joining link soon. Thank you all once again for joining us today. My name is Rashmita and I'm the event planner for Microsoft Reactor Bengaluru, India. This session will run over the next 60 minutes including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel within 3 to 4 days. I will share the link to our YouTube channel in the chat section soon. Quick word on a code of conduct. We display this at all Microsoft Reactor events that we run, and it's just a reminder to be aware of others. Key thing to take out here is to be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. Also, please keep your mics muted during the session. I would now like to welcome Vedant, our speaker for today's session. Vedant is an Indian author and a researcher. Vedant's primary area of research is in domain of applied machine learning for education. But for now, I will hand over to Vedant to begin the session. Over to you, Vedant.
Thank you, Rashmita, and thank you everyone for joining in for today's session. Let me quickly start the presentation. And meanwhile, while the presentation is going on, if you have any questions, you can definitely put them in the chat and we'll cover parallelly everything. Apart from that, we'll also have some time explicitly for questions at the end. So let me start. So today's session is not just a session, but a mission. And you are my mission associates, and I'm your mission commander, Vedant. So Rashmit already gave a nice introduction, a fabulous introduction about me. So I'm a Gold Microsoft Learn Student Ambassador. I am research assistant with University of Pennsylvania and University of Alberta. And I'm also an author. So I've published a few books and papers. You can follow me on Twitter or connect to me via my website, and I can have more engaging conversations with you in future. So let's get started. Now, what's this mission is about? So today we are talking about a mission which is called Finding Dory. But what is this mission about? So before moving on to the mission, there's a mission pre-story. So Dory is my pet. Some people have pet in form of dog, cat, but I have pet, which is my cute little fish, blue-colored Dory. You can see Dory and I swimming in the Pacific Ocean. And trust me, Pacific Ocean exists. I'm not just making things up, okay? So Dory and I are practicing and scuba diving and doing a lot of things in Pacific Ocean. So one day, what happened was Dory and her friend Marilyn were playing again in the Pacific Ocean. And while they were playing, something happened which no one is aware about because Marilyn didn't notice. Marilyn was turned back and Dory got lost. So out of blue, where did Dory go? We don't know. The poor little Dory, we don't know about her. She is just a little fish, and I don't want Dory to be in danger. So that's what we want to do. So this mission is about finding Dory, and that's the mission pre-story. Now, when I wanted to find Dory across the ocean, I got a fish named Cami. Now, what Kame does is Kame is a fish with a camera, as the name suggests, and Kame clicks photo every minute of the ocean and sends it to me. So Kame is for rescue. Now, what I can do is Kame is sending pictures. I can just go through all the pictures and can look for Dory in those pictures. And meanwhile, like through that, I can locate Dory and find her, right? But there's a problem. Our objective is to spot Dory, but the problem is there's so many pictures that Cami is sending, one picture every minute. So that's like Cami has been working for the last 3 days, and as of now, I have thousands of pictures. So what do I do about that? That's a big question mark. So that's a problem that we are trying to face, trying to solve with this mission. So while I read more about this on the internet, that how I can do this, I got to know about a solution. Let's automate this process with computer vision. Now, so if you don't know about computer vision, don't worry, we'll be going through it. But the good thing is that we have pictures of the ocean where we can find Dory. The second, we don't have to go and look at each image to find Dory. We can simply automate the process through something. We'll go to that something later. So that's the mission, and here's the mission training. So before we move on to the mission and exactly start with the mission, we have to go through this mission training where we have three terms. The first one being artificial intelligence. Now, a lot of us already know about artificial intelligence. It is so commonly used term worldwide. Be you in technical discipline or any other discipline, everyone knows about artificial intelligence. But we'll still quickly, briefly go through it, right? So AI is the intelligence demonstrated by machine. Very simply, very briefly, artificial intelligence is the intelligence, human-like intelligence, which is demonstrated by machines. Now, how can machines demonstrate it? Like, for example, we can listen, we can talk, we can see something, we can perceive things and make meaning out of it. Similarly, we can make machine works that way, where machine can see in form of computer vision. A computer can listen and do analysis on that in form of audio, and there can be further intelligent analysis on what the machine is listening or is perceiving through vision. Now, there is another term, machine learning. Now, machine learning is branch of AI or is one of the way of AI to achieve AI. So, branch of AI focused on building applications that learn from data and improve their accuracy over time. So, machine learning is one of the way to achieve AI. Now, AI is the bigger goal, and there are different ways to achieve artificial intelligence or make artificial intelligence or make intelligent machines. And machine learning is one such way, where we use data to train the machine and improve it over time with additional data. Still, if it's confusing and if you're new to this term, don't worry. You'll understand it as we move forward. The third is computer vision. Now, within machine learning, there can be a lot of things that you can train on to the machine. As I told you, can work on vision, you can work on audio, you can work on text, you can work on NLP, anything, right? And computer vision is one such thing. Computer vision is the field of AI that works on enabling computers to see, identify, and process image in the same way as human does. So if I'm doing this session today, if I'm looking at my slides, I can read, I can understand, and that's what we're trying to do. That if a machine has a camera, the camera along with the machine should be able to see things, perceive things, identify, process them, and make some meaning out of them. If you want to learn more about this, you can go to this link. I'll put the link in the chat later, and potentially you'll also receive it after the session. Now, talking more about computer vision. How does computer vision work? Okay, computer vision is about giving vision to the machine, to the computer, to identify things or see things. But how does that work? How do we do that? What's the process, right? So let's take an example. So training a machine is similar to how you train a human being or a baby. So as a baby, baby doesn't know things, right? Baby doesn't know how things are like. Similar to computer. We have a computer doesn't know what a ball looks like or what an apple looks like. Both are similar shaped objects of similar color, and thus it's difficult to differentiate between those. And even baby faces that problem. Now we want that baby to eat apple and play with ball, not vice versa. We don't want the baby to eat the ball and play with apple, right? So what will you do? How will you train your baby? So the thing that usually all the parents do is that show apple and tell the baby that this is apple and you should eat it. Now, obviously, while you are telling it, the baby doesn't understand your words, but just with your actions, while you're showing the apple again and again and feeding the apple to the baby is trying kind of understanding what the things are around. Similarly, when you give a ball and you play with the baby with that ball, the baby understands that this is a ball, something that you play with, and this is the apple that you eat. Probably for 5 days of training, still you'll find the baby eating the ball, and maybe for next 10 days, probably the same thing continue, but it won't happen for next 30 days unless your baby is mentally retarded. So, so the baby will understand what an apple looks like and what a ball looks like, and that's how computer vision work. You repeatedly pass images of certain object of certain class to the person you're training or to the machine that you're training, and the machine, after multiple understanding or after looking at multiple training data, understand what an apple and ball or what an object looks like. So I used the term training data. What does that mean? So everything that you're passing, all the resources that you have, like images or data, is basically to train the model or to train the baby or to train the computer is your training data. And once your model is trained, you want to test it, right? So once we have done this whole process of training the baby, once the baby has been trained, now we want to see whether the baby has been trained properly or not. So probably you will bring another apple which wasn't the one which you used to train the baby. So for example, I have a fresh apple in my fridge and I use that, and I have a ball in a box. I use that to train the baby. Now, obviously, the baby understands that that specific apple is an apple and that specific ball is a ball. But what we want to do is we want to test the baby's knowledge. So what I'll do, instead of using the same apple and ball, I'll go to the neighbor's place and ask, "Can you give me a ball and can you give me an apple?" I'll bring that back and ask the baby to recognize what the things are. And if the baby is able to recognize an object which it was not trained on, the baby's intelligence can be validated, right? So this object, this data that you are using to test the knowledge of the baby or of the computer is called testing data or validation data. So we have data, which is pretty clear. But then inside data, we have two types of data, training data and testing data. Testing data is also known as validation data. Training data we are using for training the model or training the computer or training the baby. And validation data and testing data we are using for testing the model or validating the model or validating the knowledge that the model has gained after training. Right? Now, this baby story was just for reference. In further slides, we won't be any longer using it. We'll be using technical terms now, which you are very aware of. Moving further. So, how does computer vision work? That we are pretty clear about. But there is another problem. So, the other problem is that you can do computer vision in, like traditionally, people do computer vision in Python. There are different Python libraries like TensorFlow, PyTorch, etc. Maybe you have heard about Python. I'm sure all of you have heard about Python, the programming language, and inside that, maybe you have heard about TensorFlow or PyTorch, which are some frameworks and libraries that one can use to create computer vision model or machine learning models in Python. And these are heavy libraries and heavy framework, right? They need a lot of computation to work to train your images. They need a lot of coding to be done, right? That's first problem. A lot of images are required. The second is a lot of higher computation is required. So you need a good computer which processes things faster. You need a good processor in your computer. And the third is that you require a lot of coding. So you need a coding knowledge. Not anyone can do it, right? You need to know what how Python works, and even in inside, even if you know how Python works, TensorFlow coding with a computer vision model is itself very challenging because there is nothing which is do as directed. There are many things that you need to update dynamically to create the model, right? Now, don't worry. That's not the thing that we are gonna do here. Until I reach this point, people are usually scared because okay, this requires a lot of coding. I cannot do this. That's where we have some resources which comes into picture, and which is the title of today's session, that is custom vision. So custom vision, that is Azure Custom Vision or Microsoft Custom Vision, is a service under Microsoft Cognitive Services, which gives you a no-code approach to train a computer vision model, right? So we understood what computer vision is, and we know about Microsoft Azure, which is a cloud service. Now Microsoft Azure has an option to create a object detection or classification model, that is computer vision based model, without any code. Okay. Now I did talk about two terms over here, that is object detection and classification. I'll quickly talk about that. Now, within computer vision, there are majorly two type of problem. One is classification and second is object detection, right? Classification is where you have multiple classes or multiple categories. For example, apple and ball. Apple is one category, ball is another category. You have images coming in, and the aim of the model, the goal of the model is to look at the incoming image and classify the image either into ball or either into apple, right? That's classification. Maybe I'll appreciate if some of you can give more examples of classification in the chat just to make it engaging. Right. And the other is object detection. Now, object detection is where the goal of the model is to detect a certain object that we want. For example, if there is a CCTV camera which is installed on the traffic signal, our aim is to detect the object, that is, detect the number plate of the car which is breaking the signal, right? So if some car is violating the signal, the traffic signal, we want the computer vision model to detect that object, where our object, as of now in this case, is a number plate, right? So those are two type of problem within computer vision: classification and object detection. Right? Now, a question for everybody: if we are trying to detect Dory, what's the task? Is it classification or is it object detection? Can we have the answers in the chat? Finding Dory, is it object detection or is it classification? I'll just wait for some moments. I see some people typing. Okay, Shreya has replied object detection. That's true. That's correct. Because in what's our sample data over here? We have data which is images which Cam is clicking off the ocean, and our aim is to detect Dory from those pictures where Dory is the object and we are detecting it. So we don't have any classes, right? So that's the aim, and that's what we are going to do today. So the first thing that you need is Dory's images, because you need a training data to train on. So thankfully, while I was playing with Dory before she was lost, we did click some pictures and I did store those pictures. So if you want those pictures, you can access this link and find the data set. Those are some 15 to 16 images, which are definitely sufficient for custom vision by Microsoft Cognitive Services. That's very amazing, because usually the traditional computer vision model that you train on Python and use certain high-end frameworks for that requires thousands of images to get a good performance of the model, right? And in here, in custom vision, you can train the model and you can get good performance of the model of computer vision model with minimum 15 images. Obviously, if you add more images, the performance will improve, but still, you need very less images to get the model working, right? So you have that folder, which the link that you can access for the dataset. Those are Dory's images. The next thing that we need is Azure subscription, right? So Microsoft Azure is a cloud service which provides lots of services within that, which helps you scale the model and make it run all the time without any problem, because Microsoft is managing it for you. Everything. So your data is stored in the data center, your services is running in the backend on the cloud, and on-premise services with variable cost, which is pay as you go, depending upon what you use and how much you use. There will be that much will be your bill for that specific time period, right? So you need Azure subscription to use Microsoft Custom Vision. Now, I'm thankful to us that Azure boy over here gave us some Azure credit that we can use, right? And I'll be using that for today's session. And finally, you read custom vision services, which we'll soon figure out. So why custom vision? As I told, custom vision is far more helpful than traditional computer vision implementation, which is very heavy in terms of computation and code. The second is data requirement. Usually, when you do traditional machine learning or computer vision training, you require a lot of data, a lot of images. While in custom vision, you can do that with just minimum 15 images. And finally, while you're doing machine learning traditionally with Python coding, you require to know lots of extra knowledge that is about transfer learning, neural networks, convolution neural networks, XYZ, which are high-end machine learning concepts. But here you don't have to know anything about neural networks or transfer learning. So this is a simple process that you can do on customvision.ai. That's the link, and now we'll move on to the website and do some hands-on. All right. So customvision.ai is the website that you can go on, and once you go to the website, log in with the email ID that you have Azure subscription on, right? Once you log in through that email ID, it will quickly provide you access directly to the system. Click on New Project, right? And you can enter project name. So we can say Dory Reactor, right? I can give some description for it that is totally optional, XYZ. Then you need to create resource. So while you're using Azure, while you go on portal.azure.com, you need to create resources and resource group under your subscription so that you can manage your projects and manage your usage of resources, right? Track and manage your usage of resources. So, for example, if I'm implementing multiple projects, like one with cognitive services and maybe another with some DevOps thing, I can create two different resource groups and resources so that I can manage two different projects separately, and I can track their usage and performance, right? So I can create resource. I have already created a resource here under my Visual Studio's enterprise subscription that I have, but you can also click on create new to create your resources. You can click on subscription, enter the resource group, the kind of resources that you have, select the location, whichever is closest to you, and the pricing tier. That's it. So once you have created the resources, you can simply from drop down, you can select that resource. Then it asks you for project type. So as we discussed a few moments ago, that there are majorly two type of projects under computer vision. One is classification and the other is object detection. In classification, you have multiple classes that you're evaluating on. In object detection, you are basically trying to detect certain object from the data set, from the images that you're having, right? So ours is an object detection model as of now. So I'll click on object detection. And then you have domains which you can go for. So pick the domain which is closest to your scenario, because the cognitive custom vision service will be able to create a better model based on that. So for example, if you're trying to detect logos or products on shelf, you can go for those because the model will have some prior information about those area, about those project, and will be able to better train your model with better performance, right? So this service will be able to help you better. But if you're not aware about what type of, if you don't have your project domain in this list, and if you're not aware about what domain your project goes into, you can simply select any general project, or you can click on general compact, because compact domains, as it says, compact domains are lightweight models that can be exported into iOS and Android and other platforms. So if you select a general with in bracket compact, it will help you create models which are lightweight and which you can also deploy and export and implement into iOS and Android services and create certain deployment web apps and applications using that. So I'll go for general compact so that we can check out what are the extendable resources and how we can export it to other platforms, right? So I'll click on create project. It may take a little while for creating your project. Once your project is loaded, you will see such screen, which you can see as of now on my screen. So there you see your project name over here on the left hand side top. On the bar above, you can see three tabs. One is training images, second is performance, and third is prediction. So obviously you don't have anything inside prediction or performance because we haven't trained anything as of now. So you'll go back to training image, right? And I have option for adding images over here. So I'll click on add images, right? I have the folder where Dory's images, which I've already shared with you. Like I've displayed the link, but I'll share it with you after some time in the chat. And I'll quickly select all the images and click on upload, right? So upload 16 images. You at least need minimum 15 images per object, right? So you can also do multi-object detection, right? For example, in this case, if we want to detect Dory, that single object, and Marlin, both in the images, you can upload Dories and Marlins both the images and tag them. You will need 15 images per tag, right? So if you are doing Marlin, Dory both, you'll have to get some 15 images for Dory and 15 images for Marlin. Basically tags, not 15 images explicitly. Maybe some images have both Marlin and Dory, so that will be counted as one. Okay, so the images have been uploaded right over here, and on the left hand side you can see you have tabs, that is tagged and untagged. So as of now we haven't tagged any images, so we just have untagged images. What does tagging means? That you need to tell your model how Dory looks like. Yes, you did pass the images, but you didn't tell the model, tell the service that what amongst this image is Dory, right? So, for example, if I click on this image, here is Marlin, here is Dory, right? We want to tell the computer vision model that which of this is Dory. So you can simply drag like this, right? On Dory's wherever you see Dory in the image, like this, and then just tag it as Dory. Right? That's done. Once you do that, your image will move from untagged to tagged, right? You need to do this for all the 15 images. But you will see one thing which is happening now, right? You can see that the computer itself, like the service itself, is suggesting you where the Dory is, because it is able to detect what is the unique area, unique part of the image, right? So a service itself is able to detect object at very first instance itself. So just you can assume how strong it will be once we train the model and do everything, right? So you can click here, tag Dory. Similarly, you can do it for all the 15 images, right? And once you have done this for all the 15 images, you can click on train. In train you have two type of training. One is quick training and one is advanced training. So as the training type says, use advanced training for improved performance, especially on challenging and fine-grained data set. Like when the data set is very challenging, for example, the object is very similar to the overall image, or when the classes are similar to each other. Like for example, detecting green apple and red apple, the difference is only color, and the shape is pretty similar. So that's a challenging data set for a service to understand and differentiate between, right? So in such cases, when you have challenging data set and if you want much more improved performance, you should go for advanced training, right? With advanced training, it takes time. Probably it will take a lot of time for training, and it will take more credits out of your Azure services. It will charge you a little more. You should have more budget for advanced training, but it is the best part, best training, like best results. It will give you the best results, right? And for quick training, you can simply go for quick training if you're just initially testing out a model or testing out a service. So as of now, since we don't have much time in this session, I'll go for quick training. Well, to be honest, I won't go for any training because even quick training takes a lot of time. So I've already trained the model. So after you do this, you can train the model and the training happens. And I'll go back to my project list and open a project that I've already trained, right? So what I did in this project was simply that I uploaded the images, um, and I have these tagged images. I've already tagged them and I have already trained them. Once you train, you go to this performance tab. Now in this performance, you can see the performance metrics of the model, right? So this model finished training today morning, that is 11/10/2021 at 1:20 in the afternoon using the general compact S1 model. As we saw, that compact helps you deploy the model for web applications and lightweight models, right? You can have multiple iterations. For example, this is the first iteration, which means that the first time you did it, I uploaded these images, I trained the model one time, so this is iteration one. Now, if I'm not satisfied with the performance of this model, I can go back to training, right? I can upload more images and again retrain the model, or maybe I can use the same number of images but train the model this time with advanced training. So since I'm training it again, it will come under iteration 2. So your performance for the first iteration won't be lost. You'll have more iterations over here in this tab, right? And you see three metrics over here. The first is precision, right? The number will tell you whether if a tag is predicted by a model, how likely it is to be right. For example, if we have if we have, for example, two classes, right? Apple and orange. So the accuracy is that whether the model was able to detect apple and oranges. The precision is that whether the apple which was detected are correct, right? So precision is defined as per class, but in case of object detection, as of now, it simply tells you whether or is your model detecting it or tagging it correctly. Recall is which tells you out of the tag which should be the predicted correctly. What percentage of your model did correctly find Dory? And mean average precision is overall a performance of your model, right? So as you can see over here, we did get good metrics, right? On the left hand side, you can see slider, which stands for threshold, probability threshold, which means that if you want the model to detect Dory, how much accuracy or how much probability or how much confidence do you want the model to tell? Like I want the model to tell that our object is Dory only if the model is 50% confident about that. So that's probability threshold. Now, if I want higher accuracy, that okay, you the computer tell me if an object is Dory only if you're 80% confident about it. So I can slide it to 80 or maybe 84 as of now, and say 90, and then I can do the performance, right? That's how it works, right? Based on how you move the slider, your performances will change over here. Once that is done, you can go for, you have these options over here, that is prediction URL, right? But before that, let's go for quick testing. So you have this option for quick testing. Now you have trained the model, so I'll click on quick testing, right? Upload image, you can use an image URL or browse a local file. So I'll upload a local file, right? For example, this one, and it does the testing on it. It might take a little while. And as you can see, it has detected Dory with 98.5% accuracy. Well, very surprised, very interesting to see that even Marlin over here is a fish, or Nemo over here is a fish. The shape is similar to Dory, but our model was able to correctly identify Dory and was able to differentiate Dory from Marlin based on color. That means our model was trained properly, right? As you can see, the model gave an accuracy of 98.5%. Like with a probability or confidence of 98.5%, the model was able to detect Dory. Similarly, you can do this for all the other testing images and even using the image URL, right? That's quick testing, which is done. Now, once you have trained the model, you have tested the model, and you are satisfied with the performance of the model, you can go for deployment. Now, there are multiple ways how you can do the deployment, right? The first is prediction URL, right? I can click on prediction URL, and this will give me some endpoint, which acts as an prediction API, which you can simply use in your application or in your web application, which very swiftly works with C# coding in Visual Studio Enterprise, and that you can use to deploy your models and also host it on Azure Web Services, right? Um, as of now, in this session, the deployment part is not in the scope of the session. That's more related to web development than related to machine learning, or more related to application development than related to machine learning, which is part of this scope of this session. So you can simply use these link, which is an API. For the first link can be used for if you have image in form of URL, and the second if you have image file, right? It also gives you instruction on how to use the API. There are also a lot of documentation that one can access. After the session, I'll share the link for that as well. Right? That's one of the way how you can deploy the model. Right? The other way is exporting it. So as we did understand and see earlier that with compact model, you have option of exporting the model, right? Which are lightweight, which you can use for iOS or Android development. So you can click on export over here, right? And it asks you to choose the platform, right? So you can go for TensorFlow, which will download the TensorFlow.lite model for you, right? You can go for vision development, AI Kit, ONNX, Core ML, Docker file, which you can simply use on Azure IoT Edge, Azure Functions, or Azure ML. Azure Functions can act as an API, REST API, which you can further use in your application. Or there are multiple other things like Vision AI development kits, which you can again use for IoT applications, ONNX, which you can use for ML.NET applications, Core ML, which you can use for iOS applications, right? I'll simply click on TensorFlow to just check how it works, right? Once I click on TensorFlow, it gives me options on how I want the model to be. Do I want a TensorFlow model, a TensorFlow Lite model, or do I want a TensorFlow Lite Float 16 model, a TensorFlow JS model, or simply Safe model? I'll click on TensorFlow Lite and I'll export. So how to use it? So they have already provided a sample code that can be found in the zip file after I export and download. So I'll click on export. It will export my model and download all the dependencies, all the files, and along with sample code in a zip file, which might, okay, yeah, the export is done. I can simply click on download. So I will have a zip file over here, which I'll quickly open. Just let it download, give it a few moments. Let me check if there are any questions in the chat. Okay, there's a question. How much in general default value should we keep the probability threshold be? So it depends, right? For example, if you have a project which is based on medical sciences, where you're trying to detect skin cancer or not based on images of skin cancer or skin patches, in there you cannot really compromise with the accuracy. You will want higher accuracy because your model has to perform better. You cannot compromise with lower accuracy because you cannot tell a patient that they have skin cancer when they don't, and they don't have skin cancer when they do. So in there, the sensitivity is high of the project. In those cases, your probability threshold should be kept higher. But in case where you can compromise over the accuracy, you can go for lower probability threshold. It completely depends upon how much accurate or how much confident you want your model to be. Right. Okay, so the download has finished. We'll click open this zip file. As you can see, let me just do large icons. Yeah. As you can see, you have sorry. You have TensorFlow.lite model over here. I'll go for readme. Okay, the readme MD file could open. Will it? It won't open like this. I'll go for labels.txt. So as you can see over here, we just have single label, that we just have single object, that is Dory. So the label.txt has simply Dory. It has TensorFlow Lite model, and probably the readme.md file provides with certain information how you can export the model or deploy the model. Those who are aware with basic Python coding, they might be aware about how you can save model and reuse it. There are multiple documentations that one can quickly use. It doesn't require a lot of coding that can be done. There are a lot of codes available. You can simply change the dependencies and files to make your model work, and that should simply work, right? That's very simple. I'll share this as well. I'll upload this on my GitHub and share the link with you all so that you can check this back in the future on how the performance, how the model works, and how you can deploy it. You can also simply go for deployment as of with simply this model TensorFlow Lite and readme.md, right? Okay, so going back to custom vision, right? Now, those who are aware about model deployment and those who are aware about how the machine learning deployment process works, we usually are retraining the model all the time. We are usually improving the performance of the model all the time with incoming data, improving it and redeploying it, right? That's the whole pipeline. So that fits very best with custom services because you can upload more images, retrain the model or advanced train the model, and simply your prediction URL will be updated with the recent model or you might have option here to which model you want to use, whether iteration 1 or iteration 2, and you can re-export the model, the TensorFlow Lite file, and then just swap it with the previous model in order to update your web app, right? In order to update your web services, and you can create different versions of your web services. So as you can see, this is very simple no-code approach which you can use for a task like machine learning, which a lot of people talk about these days on many platforms like YouTube, Twitter, social media, that how difficult it is and how a lot of students are doing this in their final year for fourth year project and so on. But as you can see with custom vision and with this Microsoft Azure services, this can be done simply with not lots of effort. You can, even a first year student or a student with basic knowledge about computer vision, which I told in the slide earlier, can do it, right? Um, Apart from this, let me also quickly talk about more services that Microsoft Cognitive Service provides, right? Apart from custom vision, cognitive services. So Azure Cognitive Services also provides you applications which are other than on vision, which are based on languages, right? So you can go for speech, right? You can deploy speech to text APIs, text to speech APIs, speech translation, speech recognition for your model. Then you have language-based projects which are on entity recognition. These are some NLP-based projects. For example, you have text, or you have some post of social media or Twitter, and you want to recognize what entity does the terms belong to or certain text belong to. You can use entity recognition. You can use sentimental analysis for detecting sentiments. For example, if you have reviews on Amazon and if you want to detect the sentiments of those reviews, whether they are positive or negative, you can go for sentiment analysis. You have Q&A maker. For example, a lot of students these days deployed COVID bot for getting information about COVID-19 and whether they are affected by it, what are the symptoms and so on. So you can also create intelligent Q&A maker. So Q&A maker simply doesn't work on static question answer. It's dynamic. It understands what similar questions they can be clubbed together. For example, if I ask what is your name, what your name is, or how can I get COVID, what are the symptoms of COVID, is it easy to catch COVID? So it can recognize, you don't have to explicitly enter these questions. It will recognize similar questions using their natural language processing. You also have language understanding and translator models, which comes with cognitive services. Other than that, you have vision, which is computer vision to analyze content in images and video. Then there is custom vision, which we just recently talked about. And there is face API to detect faces, right? And finally, there is decision making projects, which is anomaly detector to detect potential problems like anomaly. Uh, and then there is content moderator to detect potential offensive or unwanted content in a platform, and a personalizer which helps you create certain recommender model. For example, in Netflix, you have a recommendation engine which personalizes your Netflix experience by recommending you those series which you whose genre you are more interested into and more aware about, right? So that helps you with personalizer. That's about Microsoft Cognitive Services. You can read more about how cognitive services work, what are their security aspects, the scaling aspects. You can create a free account to test out some of these services. Like for custom vision, you need Azure subscription, but for some of the other, like for Face API, probably you don't need Azure subscription and it works for free. So you can check that out, right? It has some free services. For example, over here you can see that if you upload an identity card, it will recognize the face out of it, right? So let's just try it out. I can browse and go for any of my photo, any of my image, like this news article. Where did it go? There's a news article. Okay, yeah. So I'll go for this news article. Let's see if it is able to detect faces from those news article. Oh, browse. What happened? Okay, I lost it. Never mind. So you can test this out. You can simply search for cognitive services and test the service out. Okay, done. yeah, it uploaded, but it wasn't able to recognize face because probably the face is so small or something like that. But you can test it out with different data and different services and how it is performing on your data. All right, and you can quickly deploy this model, and they are very uh, uh, they're very reliable models that can be used for your deployment, right? You can also create an Azure free account. You can get 200 credit by creating your Azure free account for the first time, and that should help you with trying out these services. All right. So I guess that's about it, unless I have any slide at the last. Oh no, that's it. So that was my content for today, and maybe I can. We have 10 minutes. I can take up some questions over here, right? Uh, William asked, what about costs associated with the training this model? Do we have to pay for the infrastructure used during training? Well, for training, no, you don't use. It doesn't like you do need Azure subscription, but while you're training the model, it doesn't associate any cost with you. While you're deploying it or using the prediction URL or prediction API, then there are some costs which are associated with it based on how much you use it. But then why do I go for prediction URL when I can simply deploy the model as TensorFlow Lite model and use it for free, right? So overall, you can use the service for free. And you can explore the pricing model for other cognitive services like Face API and everything in the website that I shared. Like I'll quickly share the website that I showed earlier, right? So let me quickly share all the links that I talked about in the chat. Also, we'll be sharing it. Probably will be having sharing it with you, those who have checked in the events later. So this is the link for Cognitive Services API. I'll share the link that I had in the slide for the Microsoft Learn document that can help you with how about how you can know more about computer vision, how computer vision works. You can learn more about this from here, right? I'll also share on one of the documentation that you can use to deploy your model, right? So just give me a minute. Right. Okay. There are lots of things that are available on Microsoft's website that you can use, like how you can deploy it on Vision AI Development Kit or simply for classification using a web app on using C#. There are also sample codes available that you can explore. There's certain Medium blogs that people have referred to. You can simply search on Google. I've provided certain links, but you can also search on Google to provide, like on your search engine, whether Google or Bing, to look for more resources on how you can deploy your services. All right. I guess that's it, unless we have any more questions, which I don't see as of now in the chat. So you can always reach out to me. I did share my link, my URL. I'll quickly paste my Twitter handle in the chat so that you can reach out to me via Twitter in case you have any problem, right? Or you have any question. All right. Thank you everyone for joining in. I hope you liked the content, and yeah, feel free to reach out to me.
Okay then, so I think we don't have any more questions. So yeah, we are good to go. Thank you, Vedant, so much for hosting the session for us, and thank you all for joining us today. Please feel free to do event check-in and share your feedback about today's session. It's very important for us, and also it will help us to choose our topics better. Please visit our Microsoft Reactor Bengaluru meetup page for more upcoming sessions. Thank you all once again and enjoy the rest of your day.
Thank you. Bye.